Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is here to get to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. For the last 35 years, every 22 minutes, a special signal has been sent from space to Earth. It's not something people made, like a satellite. Instead, it's a message from deep space, a place full of mystery. Scientists have given it a name, GPMJ 1839-10. This signal, caught by one of Earth's strongest telescopes, has made people all over the world really curious. They're asking questions like, where does it come from, and why should we even care? So how can we figure out more about this mysterious signal? The key is something called radio astronomy. Let me explain. A long time ago, in the 1930s, there was a scientist named Carl Yansky. He was doing some experiments with radio waves. Then, he found something surprising in radio waves coming from the Milky Way, our galaxy. This discovery started something new called radio astronomy. Instead of just looking at space, like with regular telescopes, radio astronomy listens to space using radio waves. It's like having ears to hear things we can't see with our eyes. And since then, our telescopes have gotten super fancy. Now they can pick up signals from really far away. So, as we try to solve the mystery of the signal called GPMJ 1839-10, we turn to radio astronomy for help. It's like a special tool that lets us hear what's going on in space. And with this tool, we can learn more about the secrets hidden out there in the universe. Since the very beginning, radio astronomy has been getting better and better. Nowadays, our telescopes are super advanced. They're like the superheroes of space, able to pick up signals from places we can't even imagine. In the remote outback of Western Australia sits a space detective unlike any other on the Murchison Broadband Array. It's not just a telescope, it's a sophisticated network designed to explore the farthest reaches of the universe. Composed of thousands of antennas scattered across an arid landscape, the Murchison Wide Field Array is an engineering feat and a testament to human curiosity. Each antenna is like a finely tuned ear, listening intently to a whisper. Behind the scenes, a team of dedicated scientists and engineers work tirelessly to calibrate and maintain this complex system. What's their goal? To pick up signals over a wide range of frequencies. This is crucial for studying different celestial phenomena, as each emits its own unique radio signature. Once captured, these signals are processed in a state-of-the-art data center. Here, powerful algorithms sift through the cosmic noise to identify patterns and anomalies, turning raw data into valuable scientific discoveries. Among the most fascinating discoveries made by the array are fast radio bursts, or FRBs. These bursts of energy are incredibly short, lasting only a tiny fraction of a second, yet they release as much energy as the sun does in almost 100 years. It was while studying these bursts of energy from space that scientists stumbled upon our mysterious signal, GPMJ 1839-10. What makes this signal so intriguing is that it doesn't behave like others. Instead of appearing randomly or disappearing quickly, it has been arriving at Earth like clockwork every 22 minutes for the past 35 years. This consistency and endurance have made it a hot topic for discussion and study in the world of radio astronomy. Unlike signals that might be caused by interference or other disturbances, GPMJ 1839-10 has been thoroughly checked and verified. Despite rigorous testing, the signal has persisted, leaving scientists scratching their heads in wonder. Further observations have only confirmed its existence, solidifying its place as one of the longest-standing mysteries in the field of radio astronomy. So what makes GPMJ 1839-10 stand out? Its regular 22-minute rhythm is like the steady beat of a drum in the vast symphony of cosmic signals, providing a constant reference point amidst the chaos of space. But there's more to it than just its timing. Analysis of the signal's waveform reveals additional peculiarities. Unlike typical celestial radio emissions, its pattern doesn't match the expected profiles. Its frequency and strength show subtleties that we're still trying to understand, adding layers of complexity to an already puzzling mystery. Numerous ideas have been suggested, ranging from spinning neutron stars to highly magnetic magnetars, and even more exotic notions like the interaction between two black holes. However, none of these theories fit all the criteria perfectly, leaving scientists puzzled and intrigued. When mysterious radio signals from space appear, one common suspect is pulsars. These cosmic landmarks are known for emitting beams of radio waves, making them ideal candidates for any strange signals from the cosmos. But what exactly are pulsars? Pulsars are special kinds of stars called neutron stars. They're formed when massive stars explode in a supernova. These neutron stars spin incredibly fast, and as they do, they create strong magnetic fields. These magnetic fields generate beams of electromagnetic radiation, including radio waves. These waves shoot out into space, similar to the rotating beams of light from a lighthouse. When these beams pass by Earth, our radio telescopes pick them up as pulses, which is why they're called pulsars. These pulses from pulsars are usually very regular, often coming with precise timing down to milliseconds. This predictability has even made some pulsars useful as space clocks, helping with tasks like navigating spacecraft. So, could GPMJ 1839-10 be a pulsar? It might seem like a possibility at first because of its regular 22-minute rhythm, but if we take a closer look, we see some important differences. Unlike typical pulsar signals that have a steady shape and strength, GPMJ 1839-10 has unique features that make it stand out. Its waveform doesn't match what we expect from pulsars, and its strength changes in ways we don't fully understand. Also, pulsars usually slow down over time because they lose energy from spinning, which affects the timing of their signals. However, GPMJ 1839-10 has stayed the same for more than 30 years. To sum it up, even though pulsars are often blamed for mysterious radio signals, this time they don't seem to be the cause. While pulsars are usually the first suspects, magnetars also come into play. Magnetars are a different kind of neutron star with incredibly strong magnetic fields that are hard to wrap our heads around. To give you an idea of how powerful a magnetar's magnetic field is, it's billions of times stronger than Earth's and trillions of times stronger than a regular fridge magnet. These magnetic fields are so intense they could wipe out data from a credit card halfway to the sun. Magnetars have some strange behaviors. They shoot out X-rays and gamma rays, and they can also send out radio waves. These radio waves are often linked to stellar earthquakes, massive seismic events on the surface of a magnetar that release huge amounts of energy. Picture an earthquake, but on a cosmic scale. These cosmic tremors can mess up the magnetar's magnetic field, leading to bursts of electromagnetic radiation, including radio waves. So, could a magnetar be behind our mysterious GPMJ 1839-10 signal? At first, it might seem like a possibility, considering how strange magnetars can be. But when we take a closer look, things don't quite add up. The idea of stellar earthquakes doesn't explain why the signal keeps coming every 22 minutes for so long. These quakes are more like random events and wouldn't create the steady rhythm we see with GPMJ 1839-10. While magnetars are intriguing, we need to keep searching for a better explanation. As we keep digging into astrophysics, another idea pops up: white dwarfs. These are what's left after stars use up all their nuclear fuel. They're super dense and have strong magnetic fields, which could theoretically make radio signals. Could a white dwarf be sending out the signal we're seeing with GPMJ 1839-10? Well, their magnetic fields aren't exactly like what we're seeing with the signal. Another theory takes us to the dance between stars and the planets that orbit them. In this cosmic ballet, the magnetic fields of stars and planets can interact in ways that make unique radio signals. It's a cool idea to explore, but it comes with its own set of challenges. These interactions could create all sorts of signals, not just the steady 22-minute one we're seeing. A fresh perspective is starting to emerge considering the surroundings of the signal. Maybe cosmic debris floating around or winds from nearby stars could be affecting the signal's patterns. It's like the signal is traveling through space and bumping into things along the way, changing its tune by the time it reaches us. It's an interesting thought that adds another layer of complexity to our search for answers. Imagine a radio signal traveling through space, encountering obstacles like asteroids, gas clouds, and streams of charged particles along the way. These things act like filters, changing the signal's characteristics before it reaches Earth. This isn't just a wild idea. Studies have shown that space debris can really mess with radio signals, making them weaker or changing their pitch. So, could this be happening with GPMJ 1839-10? It's an interesting thought, one that might explain some of the weird things about the signal. It's kind of like how fast radio burst 20189-016b had some strange patterns that turned out to be because of stuff in its neighborhood, like a nearby magnetar and the stuff floating around in space. Could GPMJ 1839-10 be affected in a similar way? Even though the situations are different, the idea that space conditions can mess with radio signals adds a whole new layer to our puzzle. As we come to the end of our investigation, let's think about what this mysterious signal means and what we'll do next. Luckily, the folks who found GPMJ 1839-10 are still watching and looking at old pictures to find more stuff like it in the Milky Way. They're determined to crack this mystery, and so far, things are looking good. Finding GPMJ 1839-10 shows us that these super long radio signals aren't as rare as we thought. This means that future studies might find even more of them, helping us figure out what they're all about. And that's it. Thanks for joining us on Spaceverse as we delved into the mysteries of cosmic signals and explored the wonders of the universe. From the enigmatic GPMJ 1839-10 signal to the fascinating world of pulsars and magnetars, we've journeyed through the depths of space in search of answers. Remember to stay curious and keep looking up at the stars. Until next time, keep exploring the cosmos with Spaceverse.